Welcome to our project, Toxic Gas Monitoring and Tracking for UAV System. Meet the team from left to right. There's John Drow, Joseph Merrill, Nick Clysmith, and Paul Runkle. Here we have the back side of the
Arduino.
Uno. Here we have the Adafruit Fauna 808, which is a GPS plus GSM shield for the
Arduino.
Uno. This is a picture of how the Adafruit Fauna 808 connects to the
Arduino.
Uno. Here are the gas sensors, the MQ137 for ammonia and the MQ2 for air quality, in this case alcohol level. Here is a list of the technical constraints for our project. The sensor will be able to accurately detect when gas is present. The GPS will be able to accurately report coordinates. The system will create a text message. The system will be attachable to a UAV. The system will be able to support multiple gas sensors. Here is a list of our non-technical constraints for our project. The system will be built with off-the-shelf products and will be limited to the capabilities of such products. The system will be user-friendly in a way that first responders can easily replace sensors. Here is a list of requirements for our project. UI1. The GPS shall be able to receive GPS coordinates. UI2. The GPS coordinates received shall be accurate within 2.5 meters. UI3. The MQ137 shall read 5 to 500 parts per million. UI4. The device shall transmit data upon point detection of ammonia gas at a level equal to or above 5 parts per million. UI5. The device shall operate in temperatures between -10 and 70 degrees Celsius. UI6. The device shall communicate with a cell phone network. UI1. The GPS shall receive GPS coordinates. As you can see, the GPS has a fix and has the latitude coordinate 40.159915 and the longitude coordinate -83.954787. So this requirement is confirmed. UI2. The GPS shall be accurate within 2.5 meters. Even though it's hard to see, the test location results were 177 feet off from the actual test location. So this requirement is busted. UI3. The MQ137 shall read between 5 and 500 parts per million. As you can see, the data sheet for the MQ137 confirms that the device will read between 5 and 500 parts per million for ammonia gas. So this requirement is confirmed. UI4. The device shall transmit data upon point detection of ammonia gas at a level equal to or above 5 parts per million. As you can see, the device is transmitting data to the computer. However, our group would have liked this to be through the GSM cell phone network. So this requirement is plausible. UI5. The device shall operate in temperatures between -10 and 70 degrees Celsius. So this requirement is plausible. UI6. The device shall communicate with a cell phone network.
Can you hear me now? Can you hear me now? Can you hear me now?
That is fine.
Can you hear me now?
Go.
Can you hear me now? Can you hear me now?
Through.
Can you hear me now?
So this requirement is busted. This is not a requirement, but we did test how accurate the sensors are. To do this, we used a 50 parts per million calibration gas with a pre-calibrated sensor. Then we tested the Arduino with the same 50 parts per million calibration gas. As you can see, the MQ-137 gas sensor is sensing about 50 parts per million for the ammonia gas. Here's how the device should work. This is some regular ammonia house cleaner. We'll hold the sensor up to the ammonia cleaner. And as you can see, the LED is on. That means the system is detecting over 50 parts per million. The phone has just received a text message, and inside that message it displays the GPS coordinates, which sensor was triggered. Now we're on to the rubbing alcohol. For this we will use the other sensor and hold it up to the cap of the bottle. The LED comes on again, thus displaying that it has 50 parts per million sensed. And then we get a text message from that sensor saying that we have that sensor triggered and parts per million and the GPS coordinates. To further enhance our project, we recommend creating a custom app to receive the SMS data and create pins on Google Earth that map the toxic plume, such as the image shown.
pronouncenames.com.
Arduino, Arduino,